we need to write it in this form, indicates we're completing the square. So we take 3x squared minus 12x. We're going to separate the plus 11 for now. Factorize the left hand side, so we bring the 3 out, and we have x squared minus 4x. Now we're going to complete the square on just this portion, so we know it's half of this value, so it's going to be x minus 2 all squared. We're then going to subtract that value squared, so we're going to subtract 4. Notice this 3 is affecting everything inside this square bracket, so we're now going to expand that bracket out. So we've got 3x minus 12 minus 2 minus 12. So we've got 3x minus 2, and this is where obviously the plus 11 comes back in. So we've got negative 12 plus 11 is minus 1. The graph is translated 3 units in the positive x and 5 units positive y. So if this is our function f, we're going 3 units in the positive x direction. It means that this value here is going to become more negative. It's going to be 3 units more negative. So it's going to be 3 bracket x minus 5 squared. And then if it's going 5 units in the positive y direction, it means that this value here on the end is increasing by 5. And remember that actually goes in the same direction. So negative 1 plus 5 gives us positive. So we need to write down the values of p and q. Now this is where you've got to be careful. Sometimes it's easier to not look at the format that they've given you, and we know that the equation would be y equals, there's a potential a value here, and we have x plus 1 and x minus 3, because remember it's the opposite values to the ones it goes through. Then we need to have a look at how they've given it to us. So they've said x minus p and x minus q. So for this to be x minus p, if we've got plus 1, it means that p has a value of negative 1, because if we were to put that back in, x take away negative 1, that gives us what we actually wanted, and that gives us plus 1. And then q would just be straightforward 3. Obviously p and q can be reversed. It doesn't make a difference which one's which, but the signs are important. So p is negative 1, q is 3. We then need to find the coordinates of c. We know c is the vertex of the parabola, and that happens halfway in between these 2 points. That's 4 unit gap, so 2 units from either side gives us a value of x is 1. So we know the x coordinate is 1 at the vertex. So the vertex is where x equals 1. They've indicated there is no value of a, so our equation is straightforward. Y equals x plus 1, x minus 3. Well, if we know the vertex happens when x is 1, we're going to stick that value in to find y. So that's 2 times negative 2. So the coordinate is 1, negative 4. Write down the y coordinates of b. Oh gosh, I haven't finished. B is the y-intercept. So what we need to do is to substitute in x equals 0. So y would be 0 plus 1 times 0 minus 3, which is negative 3. The equation has 2 distinct real roots. So because we're talking about distinct real roots, we're looking at the discriminant. The discriminant is given by b squared minus 4ac. And for 2 distinct real roots, that discriminant has to be greater than 0. No, it cannot equal 0 because there's 2 different real roots. If it just said real roots, then it could be equal to 0. So in this case, A has a value of 1, B has a value of negative 2k, and C also has a value of 1. So we're sticking those values in, so it's negative 2k all squared minus 4 times 1 times 1 has to be greater than 0. Negative 2k all squared is 4k squared. So there's different ways of doing this. So we could say 4k squared is greater than 4, k squared is greater than 1. Now for k squared to be greater than 1, this is where we just need to be careful. It's like saying that we're just looking at our parabola, which is just x squared. If it's actually, no, I'm changing my mind. So at this point here, I'm going to factorize it. So I'm going to bring the 4 out. So I've got k squared minus 1. And I can see this is a difference of 2 squares. Oops, sorry, keep my notes. And this is in the form of a parabola. So that would be crossing at 1 and at minus 1. Doesn't matter all the other values. But we're saying, where is that parabola greater than 0? And that parabola is greater than 0 in these two portions. So in other words, when k is less than negative 1, or when k is greater than 1. And that's the easiest way to deal with these inequalities when something is squared. It's best to sketch it, and you can see where it's greater than or less than.